same thing Miss Riley used to.
Yes, it is. Yeah. Okay, so 16A, degrees and radians. So first things first. Okay, so yeah, degrees and radians are measured starting from the positive side of the x-axis and moving in an anti-clockwise direction. So if this is our Cartesian plane and we have our unit circle, so a unit circle has a radius of 1 in all directions and a center at the origin. We start from this point here, right? So this would be 0, and we move around this way, around the circle, so going that way. Right, so always start from the positive side of the x-axis and go around the circle in an anti-clockwise direction. Now, 1 radian is the angle at the center of the circle with an arc length of 1. So what we find is if that's the radius 1 there, and we go an arc length of 1, so that curve around there is like 1 unit, then that is the angle in here is 1 radian. Yes? Right, just the distance around the outside of the circle here is 1 unit, same as here, it's 1 unit, right? This angle in here is called 1 radian. Right, and what you actually find is that there is exactly 3.141592, right, radians that fit inside a semicircle. So it's pi, yeah.
So when it's 8 meters.
Yeah, when it's not just me freehand sketching, when you actually measure it out, there is exactly 3.141592 of those radians in a semicircle. Okay, so 3.141599, blah, blah, blah. Therefore, 180 degrees equals pi. Similarly, the whole way around the circle, what do you think it's going to be? 360 degrees, how many pies? 2 of them, yeah, 2 pi. Okay, let's just squeeze in here. So just like you've got a symbol for degrees, that little circle, you've got a symbol for radians. It's a little C up above, but you very rarely see it. Just don't freak out if you see a little C. It just means radians. Okay, so we've got, let's draw our unit circle again.
Is this an example?
Not quite, it's more explaining. Thank you.
Wow.
Right, so we always start here, and that's 0. If we go the whole way around the circle, right, this point is, we said before, was pi. We come the whole way back around the circle. 0 is actually also 2 pi. They're equivalent. Right? So what do you think this point here is going to be?
Half pi.
Half pi, yeah, or pi over 2. Because you take pi divided by 2, it's same as half pi. Right? What do you think this point is going to be?
3 pi and a half.
3 pi on 2, yeah, 1.5 pi. What about this point here?
No,
What was it?
pi.
It's a quarter pi, yes. Pi on 4. Yeah? What about this one here? 3/4 pi, yeah. 3 pi on 4. What about this one down here?
8 pi on 4.
Not quite.
6 pi.
Right, so start here. I got 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. 7 pi on 4. Right? Let's try about here. Right, so imagine that your first quadrant is cut into 3. What do you think this one here is going to be? No, pi on 3. Remember, pi is all the way around to here. Not pi on 8. Right, imagine that we're cutting each quadrant into 3. How many sections do you have? 1, 2, 3, 4, 5, 6. And this is pi over 6, yeah. Right, this one, what would it be?
Pi on 8, 6, 9, 10.
This is a sixth. This is
7.
2/6.
12.
Yeah, pi over 3. Right, because 2/6 is a third. Pi on 3. What about this one? Any ideas? All the yellows are divided into six pieces. So you got 1/6, 2/6, 3/6, 4/6. How do you simplify 4/6? 2/3. So you got 2 pi on 3.
Wow.
Right? What about this one down here? Not quite. Right. 1 6 2 6 3 6 4 6 5 6 6 6 7 6 8 6 9 6 10 6 11 sixths. 11 pi on 6. Right? Notice that if we start at 0, we go around to pi, we go back around to 2 pi, and then we go around again, we get 3 pi. So 3 pi and pi mean the same thing, right? Go back around again, you get 4 pi. Right? You can keep going around and around, and they're going to mean the same thing.
Is the same number?
Yeah, so 0, 2 pi, 4 pi, 6 pi, 8 pi, they're all equivalent. Okay? Same with if you went in quarters, and you go 1 quarter, 2 quarters, 3 quarters, 4 quarters, 5 quarters, 6 quarters, 7 quarters, 8 quarters, 9 quarters. 9 pi and 4 is the same as pi on 4. Because it's a full 2 pi plus another quarter. Right? So every time you come back around to this point here, it starts all over again. And then they're equivalent. Okay? So, we see that 0, 2 pi, 4 pi, 6 pi.
Oh.
Right? All right, so now if we move clockwise, so the other way around the circle, what you see is the same values are rising, but they'll be the negative. So let's draw our little unit circle again.
Will it be negative pi?
It will be, yep. Right, so 1, negative 1, negative 1, 1. So we start here at 0. We're going to go around this way, right? Because we're going clockwise, it's negative pi. Right, keep going around. What's this one?
Negative 2 pi.
Very good, negative 2 pi. Right, what would this one be?
Negative 3 over 2.
Now remember that you're going clockwise, so it's halfway to pi, halfway to negative pi, sorry, so it's negative pi on 2. Right, so it's going this way. What would this one be?
Negative 3 pi.
Negative 3 pi on 2, yep. It's 1.5 pi. Same, what would this one be? Start at 0, go.
Negative
No, you start at 0. You're going a quarter of the way towards pi. Oh, sorry, negative pi. So it's negative pi on 4. Right? Ooh. Oh no. We're all good?
Miss, you should just upload this on YouTube. Make a channel.
Would you like it on YouTube as well?
Yes, getting so many subscribers.
I've got a channel ready to go if you want me to put it on both websites.
I think you should just
Okay, what would this point be? We start at 0. Negative a quarter. Yes.
Isn't that first look like someone everything negative?
Yes. It's going to look like the very first circle that we did, but you're just going the opposite way around the circle. So it's all the same values, but just going around clockwise. Because you're going 1 quarter, 2 quarters, 3 quarters. This year. Yeah, a half is 2 quarters. Yep. Yeah. So we won't go through every single angle, but you get the idea. It is just the negative. Yeah, it goes the other way around the circle. So last thing, we got 0, negative 2 pi, negative 4 pi are all equivalent. Also, what we saw before, if we go up this way, it's going to be 1, 2, 3, 4, 5, 6, 7. So negative 7 pi on 4. But we saw before that it was also pi on 4 when we went anticlockwise. So you can say that negative 7 pi on 4 and pi on 4 are equivalent. Yes?
At the bottom where is that like negative 1 minus?
It means at the point negative 1. It's the radius.
Oh, okay.
Yeah. Last little bit. Yes. Good. So, converting from degrees to radians. How do we convert 30 degrees into radians? You can, yep. We can definitely plot it. Right, whereabouts is 30 degrees?
Just a bit under halfway of the quarter.
Be more exact.
Ooh,
Right, if we take this 90 degrees
pi over 6.
and we split it into thirds, yeah. Right, if we split that into thirds.
Just on pi over 4.
Right, so it's this one here. You can read that. It says 30 degrees. Okay, so if this is pi here, we start here. How many sections is pi split up into?
3.1415.
No, 1, 2, 3, 4, 5, 6. And this is one of those. 1 pi on 6.
Times 30 by 5 and divide that by 180.
Exactly, yes. So what you do is you times it by pi on 180. Exactly what you said. And the reason that you do that is because pi equals 180. Your multiplying by 180 on 180, right? Which equals 1, obviously. So,
Pi equals 360.
no, we said before pi equals 180. It's from here round to there. 2 pi is a full 360. Yeah. Let's get rid of that. So you're not changing the value at all. Right, so when we times over here by pi on 180, we're not actually doing anything to this degrees because we're just basically timesing it by 1. Pi on 180 is 180 on 180, which is 1.
Pi is 180.
Yeah, so by multiplying it, because you can't just multiply willy-nilly, like whenever you feel like it. So by multiplying it by pi on 80, we're not actually changing the 30 at all because we're just multiplying it by essentially 1.
So the answer would be 30.
Hold on.
No.
Remember, how do you multiply a whole number onto a fraction? Times it onto the top. So you get 30 pi on 180, right? Simplify that fraction. You don't need a calculator. Yeah, pi on 6. Yeah, exactly. Right? So here's your rule. To convert from degrees to radians, multiply by pi on 180. That's all there is to it. There's no difference, so right, 270 degrees, you multiply that by, no, it's always pi on 180.
If it's like, you go around and you have like 9 pi, it's just you times it. Like if it's that sort of
9 pi on 4 is, well, are you trying to convert back to degrees?
So you go from, so
If it's 9 pi on 4, then it's a full 2 pi plus another quarter.
it's like that degree. Would you like saying 400 do that?
Yeah, if you go more than 360 degrees around, then it would just become the simplest form. So it'd be pi on 4. Yeah. Okay, so you get 270 pi on 180, which you simplify 3 pi on 2. Yep. There you go. Which makes sense because 270 degrees is this point down here, which we know is 1.5 pi's. There. Okay, very last one. Converting from radians to degrees. Other way around. So if we're given, for example, 5 pi on 3. Now this one is even simpler because we know pi equals what?
180.
180. So sub it in. Yay.
Wow.
Right. So 5 times 180 on 3.
300.
Is it 900?
300. How is 5 times 180?
Just 900? Yeah. right, which equals 300 degrees. Okay, so here's your little rule to convert from radians to degrees. Sub in pi equals 180. So 7 pi on 8. Try that one. So yep, sub in your 180 with the 8. Now if you want, you can do the 7 times 180 and then divide that large number by 8, or you can do some cancellation first, whichever you prefer. So if I divide this by 2, I can divide this one by 2. I see that they're divisible by 2 again. Probably not. So you can simplify it down to this if you like. You have to think back to year 8 doing long multiplication and division. Right, so you got your 45 times by 7. 7 times 5 is 35. Write the 5, carry the 3. That's 28 plus 3, 31. So 315 divided by 2. Yes, 157.5 degrees. So 7 pi on 8 is equal to 157.5 degrees. The end.